There's a knight on the a1 square of an otherwise empty chessboard. Can it reach h8 while landing exactly once on each square? Let's find out. Chess is known for the insanely high number of possible positions. In his 1950s paper, Programming a Computer for Playing Chess, the American mathematician Claude Shannon estimates that there are at least 10 to the power of 120 possible games. This outrageous number now bears his name and is greater than the number of atoms in the observable universe. By a vast margin. But let's go back to chess and to our puzzle in particular. We have only one piece and have even imposed a constraint on it not to land on the same square twice. But even these idealized boundary conditions allow for more possible knight moves than we can compute in a lifetime. So what are we to do? Luckily, we don't need a supercomputer and an indefinite amount of time to solve the puzzle. And after you've subscribed to my channel, I'll show you how a few observations are all it takes to find the answer. First, we notice that whenever the knight moves, it lands on a square of a different color. This is because it moves two squares horizontally or vertically, and then one square perpendicular to that. As a consequence, since the knight is standing on a black square, it will be standing on a white square after 1, 3, 5, or any odd number of moves. And after any even number of moves, it will be standing on a black square. The second important observation is that the knight must reach h8 on its 63rd move in order to visit every square in the process. This is because we have 8 times 8 equals 64 squares in total, and a1 has already been visited. But 63 is an odd number, which means that the knight will be standing on a white square after 63 moves, and h8 is black. Therefore, no matter what you do or how good you are at chess, you cannot drive a knight from a1 to h8 by landing on each square only once. And that's the power of mathematical thinking.